Welcome to the second part of the correlation analysis using R. So in a first part, we talk about what is the correlation, what is the covariance, what is the causation, and then we discuss different types of correlation coefficients, okay, and under what condition we are going to apply the Pearson correlation coefficient, under what condition we are going to apply the biserial or the point biserial correlation coefficient. Now, similarly, under what condition we are going to apply these correlation coefficient and bootstrapping technique and the partial correlation coefficient. So in this particular section, we are going to talk about the parametric correlation coefficient. The first of all, that is basically the Pearson product movement correlation coefficient, as well as we will talk about the non-parametric correlation coefficient, Spearman's, Kendall's tau, okay, as well as bootstrapping. So first of all, when we are saying the parametric correlation coefficient, and the first type of the parametric correlation coefficient is basically the Pearson product movement correlation coefficient, which we are representing through R, and we know that the correlation coefficient answer is lies always between -1 to +1. Okay, and how we can calculate this correlation coefficient? We can calculate using these formulas. So, any formula you can use out of these, either you can apply this particular formula or this or this or this, all are equal, so in order to find out the correlation coefficient. But before finding the value of the Pearson's correlation coefficient, the important thing which we need to test is that we can only apply this Pearson correlation coefficient if the data follow the non-normal distribution, mean it's a parametric, right? So both the variables, okay, both the variables must be the quantitative variable, or you can say the interval scale variable, right? And the second thing is they must follow the normal distribution. Then in that particular scenario, we can apply the product movement Pearson correlation coefficient. So this particular value, this R value, is basically the descriptive value of the correlation, mean that is the relationship between the two quantitative variables. So similarly, we can also test whether the value of R is significant or not. So for that, we discussed that our H naught, mean our null hypothesis, should be that there is no relationship between the two variables, whereas alternative mean there is a relationship between the two variables, two quantitative variables. So this is the testing of hypothesis perspective. So this is called as two-tailed test, right? Similarly, we may have, that is the correlation coefficient is greater than 0, mean there is a relationship between more than or equal to 0, or alternative mean there is less than 0 relationship, mean negative relationship. So similarly, if we have less than or equal to, or H naught would become, that should be greater than. So this is called as one tail test, right? So it could be any condition, so you can test this one. Okay, if we talk about the non-parametric perspective, so the first is obviously the data must be the quantitative data, okay, of the both the variables, but it might be follow, they do not follow the normal distribution. They could follow any particular probability distribution, right? The data might be follow exponential distribution or gamma distribution or any other kind of distribution. Then you can apply these non-parametric analysis or the correlation coefficient. But generally, people are saying that you can apply Spearman's rank correlation or Kendall's tau when your data having the ordinal scale type, right? But so how the now the question is how we can find out the Spearman's rank correlation. The formula is over here, because this method is purely basing on that we are actually ranking the data ascending order, okay, and then we are calculating the correlation between them. So similarly, the Kendall's coefficient is also a similar type of the Spearman's, mean it is also using the ranking perspective, but normally we prefer the Kendall's tau correlation coefficient when the data set is small, okay, when you do not have the large data set, okay, you have the small data set, but the ties between that those variables are large enough, okay, then we can apply the Kendall's tau test. And the third one is the third technique which we can apply in the non-parametric is the bootstrapping. So we have already discussed in the previous lecture, like what is, or you can say in the part one, what is a bootstrapping. So we will also discuss in this lecture as well quickly what is the bootstrapping and how we can apply it using R. Okay, so for that I'm using the same data set which we have used in the part one, which is a exam and anxiety data. So in the column A, we have the code, or you can say the respondents, respondent one, respondent two. And this revise is basically indicating the total hours spent for revising the exam, or you can say revising the syllabus. And then the C is basically the exam marks in percentage. The D column, which is the anxiety, which is basically the anxiety score. Okay, and then we have a gender variable. Now using R, we want to analyze it. So if we are want to analyze between any two quantitative variables, such as we are going to use exam variable, basically it's exam performance, an anxiety variable, and the revision time, which is in hours. Okay, so what we can do if we want to perform the correlation. So the first thing is we can apply the graphical analysis, which is a scatter plot, and then we can apply the correlation. So let me show you in a R, and then we will come to this graph interpretation. So for that, first of all, I need to load the data in R. So there are multiple ways to load the data. So the one of that is that I can use read.csv, which means I have the data set in a CSV format, and file.choose and header is equal to true. So file.choose the function, it will pop up a menu and allow me to pick a particular CSV file. And header is equal to true mean the first row of the data having the name of the columns. So if I run it, okay, so as I have told you, it will pop up the menu and you can see that here we have the CSV, that is a comma separated value file. I can pick it and open it. So now this data set is stored in the exam data, you can say variable. But if your data is in .dat format or in a text format, we can use this particular command. Okay, so either I can use file.choose, or either I can use, if your file is available in the same folder where you have created the R project. Okay, so you can also use this particular command. Okay, only read.dlme. Okay, and then name of the data file with the data type and header is equal to true. So this will also do the same thing. So if I run it, so now the data is in this particular variable, which is exam data. So with the help of this function, I can see the name of the columns, or you can say name of the variable. So this is the first column name, second, third, fourth, or fifth, or you can say name of the variables. If I want to see the data set, I can use view function, and remember that R is a case sensitive statistical programming language where V should be the capital. So if I run over here, so now I can see the data set. Okay, so this is the first, second, third variables, right? Now, in order to apply the scatter plot, what I am going to use is I am going to use the ggplot2. Okay, so first of all, whenever we are going to use a particular package from the R, so first we need to install it. So from the package, okay, you can check whether you have the ggplot2 or not installed. So I have already installed it. Okay, so you can just click it, or either you can simply by calling, you can write on library ggplot2. So if you do not have this package, you can click on the install, you can write ggplot2. Okay, make sure your computer is connected with the internet, and then you can install it. So once you install it, either you can write library ggplot in order to call this particular package, because we are going to use different functions that are available in this particular package, or either I can simply click over here, so it will automatically call this particular package. So from this particular package, what I am going to do is I am going to apply the scatter plot. Okay, and I'm interested in finding the relationship between the exam anxiety and the exam performance in terms of marks. Okay, so for that, what I need to do is I'm saying that ggplot, okay, that is the name of the function, and I want to draw a plot of exam data, okay, that is basically the data frame which we have already stored in this particular variable, and then I am saying that what kind of the variables I am calling, mean against what I am going to apply the plot. So that is basically the anxiety and the exam, okay, and then I am saying scatter plus, which means this particular variable, which means this function is continuous because I need to tell what kind of graph I'm going to apply. So that's why I'm saying scatter plus, okay, or either you can simply write plus over here and so on, you can do that, okay. But right now, after making a frame, so now I am saying that scatter, that is the name of the variable, plus gg gum underscore point function, which is basically draw the scatter plot, and I am labeling x-axis and y-axis. So if I run this command and run this command, so I can see that from the plot section, on the x-axis we have the exam anxiety, on a y-axis we have an exam performance. So let me interpret it, how we can interpret this particular graph. So I have also written here the commands which I have used in the R. So from this, first of all, we can see that the majority of the students suffered from the high level of anxiety. Okay, so due to the exam pressure, we can conclude that majority of students do suffer in the high level of the anxiety. Very few have the less than 60 percentage of the anxiety level. Okay, and the second thing which we can find out that there is no outlier, which means all the data points are lying nearhood with each other, okay, the neighborhood of each other. So that's where there is no extreme point, such as maybe data point lie over here or over here from you can say away from the other data points. Okay, the next thing which we can see that the students with the low level of anxiety are almost always associated with the high exam mark score. Okay, so which we can see that if your anxiety level is low, okay, your exam performance is quite good. Okay, furthermore, and having the high anxiety, so there is a lot of variability in terms of the exam performance. If there is a high anxiety level, so we can see that there is a lot of variation in the results, right? Furthermore, we can say that there is a no such case we have found that having the low anxiety and having the low performance, there is no such data point. So which means if there is an anxiety, it might be possible you perform maybe better or maybe low, but there is a lot of variation depending upon the student, okay. Furthermore, if I want to find out, so I have just incorporated two more elements. The same command will remain same. Now I am saying coloring with gender. So now I want to find out out of all these data points, because in the data set, one of the variable is a gender. We can see that whether male are doing something else in the anxiety or whether the female. So we can see that there is no such difference we found whether the gender is male or female. Okay, almost similar kind of performance they are performing. Okay, so no matter whether it's a male or female, if they have the anxiety level low, okay, their performance must be good. Okay, but if there is an anxiety level high, so their performance having lot of variation. Okay, no matter whether it's the gender is male or the female. Okay, now let me draw this gender plot with the help of this gender category. So as you can see that over here, and then we have also label it with color gender. Okay, so let me run this command, this one. So now you can see this one. Okay, now in order to apply the parametric correlation coefficient, which means the Pearson's correlation coefficient, so we have to check the normality of the data. So how we can do that? So there is a different way to check the normality. Either we can draw the QQ plot, either we can, which is quantile plot, either we can use histogram or the descriptive statistics, and the most importantly, either we can apply the test for normality. And there are multiple type of tests. So let's check one by one with the help of these, whether the data follow the normal distribution or not. Okay. So first of all, I'm using the descriptive statistics. Okay, the thing which I am going to show. Okay, but let me show you in the, you can say from the R. So first of all, we are going to draw a histogram of which variable, that is the exam anxiety. So what this function is going to do is, that is basically, for in order to draw a histogram, we should use hist, then the name of the variable in which we have stored the data, which is basically the exam data, and with the help of dollar sign we can access the particular column. So let me show you. If I press dollar, we can see that the list of all the variables in the exam data. Okay, and then I am going to store this histogram into this particular variable. So if I run it, I can see the histogram. So from this histogram, we can easily see that this do not follow a normal distribution. Okay. So if I run this particular variable, you can also check the counts. Okay. You can also check the breaks, that is 0 to 10 class, then 10 to 20 and so on. You can also check the counts and then the probabilities. Okay. The midpoints of each class. Okay. So similarly, let me draw a histogram of the second variable, which is the exam performance. If I run this, so we can also see that it might be normal, but I'm not sure because histogram is a descriptive, but it might be possible it's a normal. So we are sure from the anxiety, from the histogram of the anxiety, that it didn't follow the normal distribution, but it seems might be possible. But let me apply the QQ plot of the exam anxiety perspective on the variable of the exam anxiety. So for that, we can use this particular function, which is a Q plot. Sample is equal to an exam anxiety. So if I click over here, so I can see the exam anxiety graph. Okay, sorry, the QQ plot graph. So if this dotted line is straight, then we will say that the data follow the normal distribution. But right now it is not a straight line. So that's why this data do not follow the normal distribution. So let me draw for the second variable. So in a second variable, it might be possible, as we have seen from the histogram, might be possible it follow a normal distribution because it is look like approximately a straight line. So now let's try some descriptive analysis. So if I run this describe function, so which is available in this particular package. So again, in order to use this particular function, we need to install this package. So I have already installed this particular package. So now I need to call it. So I will run it and then describe. So from here we can see that the value of the skewness is negative 0.36. So as we know that if the value of the skewness is 0, then we will say the data follow the normal distribution, which it doesn't look like. Similarly, if the data is a normal distribution, we can also that the mean value and the median value must be equal. Okay. So from here, we cannot say the data follow the normal distribution. So another way is I can use this particular package, and in this particular package, there is a function called stat.des, which means describing. Okay, and we want to check whether the data follow the normal distribution or norm. So that's why I'm writing norm is equal to true. Norm mean normal distribution. Okay, so if I run this, so the advantage of this function is we can also apply the Sapiro-Wilk test, which is checking the normality of the data. So how we can do that? We can see that if the p-value of the Sapiro-Wilk test is greater than 5%. So how we can check that? That is basically, that is when we are saying the data follow the normal distribution in terms of the testing of hypothesis, over there we can write down H, the data follow normal distribution. Okay, whereas H1 would be the data do not follow the normal distribution. So what's the rule is, if the p-value, okay, whether you are going to apply Spiro-Wilk or any other normality test such as Anderson-Darling test, Okay, so if the p-value is greater than your pre-decided alpha, such as 0.01, which means 1% or a 5%. So if the p-value is greater than this one, we will say except h naught. Except h naught means that data do follow the normal distribution. If the p-value is less than alpha, then we will say data do not follow the normal distribution. So as we can see that from this particular command, okay, what we are getting is that is basically we are finding the normality of the data of the two variables, okay, with the help of this particular command. How we are using it, we are calling the exam data, that is a variable in which we have stored, and we are calling two variables, okay. So we haven't mentioned the row, we said comma and the column. So that means all the values in these columns, okay? And we are checking the normality. So for the exam anxiety, if we check the p-value, okay, from the Spiro-Wilk test, which is a test statistic value, because this p-value is less than alpha, we will say reject h naught. That means data do not follow the normal distribution of the anxiety variable. Similarly, if we check from the exam performance, because the p-value is again less than alpha value, which is either you are using 1% or a 5%, okay, the data do not follow the normal distribution. So theoretically speaking, we cannot apply the correlation coefficient on these two data sets. We have to use some non-parametric. But for the just practice purpose, we will find out the correlation coefficient between these two variables using the Pearson. But practically, you cannot apply the Pearson correlation coefficient between exam and anxiety because data do not follow the normal distribution. So we have to select one of the non-parametric method. So you can also get these values with the help of this command, which is a Sphero test. Okay, that is a Sphero-Wilk normality test. You can check that if I am calculating the running this command with the help of exam anxiety, mean that is a second variable. So this is a p-value, this is a test statistic value, which is the same these two values. Okay. Similarly, for exam anxiety perspective, these are the p-value and the Spiro-Wilk test value, which is we are saying that this one. So let me run these two commands in R. Okay, how we can do that? So first of all, we want to find out the descriptive analysis of more than one variable. So we can do that. Describe exam data, that is a variable in which we have stored the data, and we are accessing the two columns of the anxiety name and the exam. So if I run this one, so I can see that in anxieties variables descriptive analysis as well as the exams variables descriptive analysis. Okay, the next one is that is if I run this particular command, we can see that this is showing us the Spiro-Wilk test as well as the descriptive analysis as well as the confidence values. But from the Spiro-Wilk test, we can easily say that the data do not follow the normal distribution. One more thing, as you can see that this is a scientific notation. Okay, this is a decimal notation. If you want to see this decimal notation over here, then you can use this particular command, which is option typing is equal to 99. Okay, if I do this and run this particular command, and now again if I run this one, now you can see that it is showing me in a decimal places instead of the scientific notation. Or either I can apply the Sphero.test, that is the name of the function to check the normality of the data, and then exam data dollar sign, the name of the variable against which you want to apply the Sphero-Wilk test. Similarly, for the exam anxiety, from both the tests, as we have concluded earlier, that the data do not follow the normal distribution. So basically, for exam anxiety as well as exam performance, if we want to find out the correlation between these two variables, we cannot apply the Pearson's correlation coefficient. We have to pick among the one of these three methods, either Spiro rank or a Kendall's or a bootstrapping. But for just practice purpose, currently what I am going to do is I will apply the correlation, Pearson correlation against these two variables. So for this, I'm using a function called cor, which is a correlation. Okay. And then the first variable and then the second variable, and then I'm mentioning the method, whether I want to find out the Pearson correlation coefficient, whether I want to apply the Kendall's, so then I need to write Kendall, and then whether I want to apply the Spearman's. Okay, so right now I am applying the Pearson's correlation. So let me run this command. Okay, so what I'm getting negative 0.4409. So how we can interpret it, that from here, that they have the negative relationship, okay, between the an exam performance as well as the anxiety variable. So as the anxiety levels start increasing, the performance having the negative impact, okay, it will start decreasing, which we have already seen from the scatter plot. As well as the exam anxiety increases, the exam performance trends decreasing, so it's a negative relationship. But now we need to see that whether this relationship is significant or not. So for that, we need to test it. Okay. So before running this coefficient of determination, let me run to apply the test. So how we can apply? So for that, we have a command called cor.test. Okay, and then the name of the two variables against which we are going to apply, and then what kind of alternative you want to apply, whether it is not equal, okay, whether it is less than, or whether it's greater than. Okay, so right now I am using less than. The method is Pearson. The confidence level I want to use 99, which means the alpha is 1%. So if I run this command, okay, so from here, this is the value of the correlation, this is the value of p value. So as we have already discussed, because this p value is less than alpha, which means not the greater than alpha. And what is the alpha? Which is 0.01, because we have considered the confidence level is 99%. So that means the alpha is the 1%. So this p value is not less than alpha. So that's why we can conclude that the data do not have any relationship between these two variables. Okay. So as you can see that for using this particular function, you can, if you want to use the two tail test, then you need to use two-sided or less than or a greater than. So for the method, if you want to apply the Pearson, write down Pearson. If you want to apply the Kendall's coefficient, then you can apply Kendall or a Spearman. So right now I have applied the Pearson correlation coefficient, right? Similarly, I can also find out the uh, coefficient of determination. So coefficient of determination is what? That is basically the square of correlation coefficient. Okay, let me run this particular command. Okay, this is correlation. Okay, basically it is right now representing in terms of all three variables between exam performance, exam anxiety, as well as the revision. So this is indicating the value of the correlation coefficient value between exam anxiety and exam performance. And similarly, this is revision between exam performance. This is between exam anxiety and revision. So we can see that exam anxiety and exam performance, they have the negative relationship. Revision and exam performance having the positive relationship, whereas anxiety and revision having the negative relationship. Okay, so this should be 1, as we can see that, and obviously these value would be the same like the upper one. And over here, this is the coefficient of determination, which is basically the square of this one. So what's the coefficient of determination? The coefficient of determination is always the square of the correlation, okay? Which is basically indicating the overall variation, how much variation the one variable can explain in the others, okay? So that is basically indicating that the exam anxiety can explain 19% variation in the exam performance, okay? Similarly, the 15 or almost 16% variation can explain of the revision variable in the exam performance, or you can say the contribution for this particular variable. So similarly, we can also use another you can say package, which is basically a graphical user interface package, that is basically R command. So so for that, what we need to do is, again we need to call that package, Okay, let me call. So if I run this particular command, okay, now right now it is calling that particular package. There is another window which is basically the R commander window. So for that, first of all, we need to access the data. So for that, I will go to data, import dataset, and then I need to tell what kind of data file you have. So right now I have the same dataset in the Excel format. If I run over here, okay, and simply press OK, and then I can pick this basically the Excel file over here. This is an exam anxiety data file. So if I run this one, if I click the view tab, so this is basically the exam data we have imported. Okay, so in order to apply the correlation, what I need to do is I need to go to stats. Then I can either apply the correlation matrix or the correlation test. So you can check what's the difference. So if I let me show from the PPT. Okay, so that is first of all I'm checking the normality. I will come later. Okay, with the help of our command. So either we can pick the correlation test, okay, or either we can pick the correlation matrix. If I select correlation test, so then we have get this particular menu, and from this we can pick any two variables like anxiety as well as exam. So I can select what kind of the correlation you want to apply, the Pearson product movement correlation coefficient or the Spearman or Kendall's. Okay, whether the test is two one sided. Okay, you can pick your choice from this one, and then simply press OK, you will get the result. Similarly, if you are going to pick the matrix, so from that you can also apply the partial correlation coefficient, which we will discuss later. But over here in the matrix, there is no option for the Kendalls, so you can only apply Pearson or the rank. Okay, so right now we want to apply the Pearson correlation coefficient, so it's up to you. Either you can use this one command or this one command, so you will get the results. Okay, so let me show you through our commander. So what I am going to do is stats. First of all, I'm going to matrix, anxiety, and the exam variable I am selecting with the help of control button. Okay, so first I will select the exam anxiety variable, then pressing control, then I will click exam Pearson. Okay, and then I want to get the pairwise p-values. So that is basically I also want to apply the testing of hypothesis. If I press OK, so you can see that this is basically the answer between the correlation coefficient value, which is R, and it is also telling us how many observation, I mean the number of data points. This is also indicating the p-value. Okay, so this p-value is less than 1%, which means this is a significant relationship, which means the H naught is rejected because over here the H naught says there is no relationship, whereas H1 says there is a relationship. So as we can see that this particular p-value is less than your alpha, which is either you can use 1% or a 5%. So this is less than 1%. So that means we will say there is a significant relationship between the exam anxiety and the exam performance, and they have the negative relationship. As the anxiety levels start increasing, the exam performance will be decreased. Okay, so it is also showing us the adjusted p-value. So whichever you want to use, whether you want to use this particular value or this method, so both, with the help of both, you are getting the same result. Similarly, you can also use this particular command as well in order to find out the Pearson correlation coefficient with the help of R commander. Okay, so earlier as I told you that with the help of core or core test, which we have already applied in order to get the correlation coefficient, there is another command you can use in order to find out the correlation coefficient, which is RCORR. But for this you need to use this particular package, which means you need to install this package and then call this package in order to apply this function. So over here I am showing you the difference between these functions. If you are going to apply this function, you can get the Pearson correlation coefficient answers, Spearman's, Kendall's, but you wouldn't be able to apply the test statistic. Okay, over here test means you would not be able to get the p-value. Okay, where over here you can apply all three, as well as you can also get the p-values, as well as you will be able to get the confidence interval. Whereas if you're going to use this particular function, so you would be able to use Pearson as well as Spearman's, but you cannot apply Kendall's coefficient, as well as you will get the p-value. So we have already discussed how we can interpret it. Let me quickly discuss again. So if the p-value, as we have told you, if I am going to apply, because this is less than, which means I am saying that the h naught is greater than or equal to 0, or alternative is less than 0. So okay, because this p-value is less than how much confidence level we have used. We have used 99%. The alpha value is 0.01. Because this p-value is less than this one, we will say reject h naught. Okay, so if we are rejecting h naught, so that means there is a negative relationship between these two variables. Which two variables? That is exam performance as well as the anxiety level, right? And the value of the correlation coefficient is this. Okay, now as we have discussed earlier, if the data do not follow the normal distribution, or we haven't measured it in an interval scale, we have measured in an interval scale, sorry, in an ordinal scale, then we have to apply the non-parametric correlation. So for that, either we can apply Spearman's correlation coefficient or Kendall's or bootstrapping. Okay, so for that, what I am going to use is I am going to use a data set that is biggest liar data, that is basically having the two columns right now. One is the creativity, another is a position. So what this data says that I have basically want to test the theory that the more creative people will be able to create the you can say false story. They can make the false stories. So what I have get is I have get the 68% contestants data, and then I have also get their position, so their creativity and their position. So which mean more you have created the false story, you will get the higher position. Okay, so this creativity is basically, you can say, the marks, right? So because the position is an ordinal scale data, and we want to find out the relationship between the contestant's position and the creativity. Although creativity we can say that in trouble, but this is ordinal, so we are going with the non-parametric analysis. So for that we will going to apply the Spearman's correlation as well as Kendall's coefficient. Okay, so first of all, with the help of this command, which is I'm using the R, okay, I'm accessing the data. I can view this data set. Okay, then I am applying this command in order to find out the correlation. Okay, the H1, which means I'm saying that H naught rho is greater than or equal to 0, whereas alternative is rho is less than 0. So that means over here I am saying that they have the positive relationship or a no relationship, whereas over here we are saying that there is a negative relationship between these two variables. So once I have run this by writing the Spearman's, I am getting these values. So rho is negative, this one. So from this we can easily say that, so they have the negative relationship, as well as by default the alpha is 5%, this p value is less than, so we can easily conclude that there is a significant relationship between the creativity score and the position held in the world's biggest liar competition. So they have the negative relationship, right? So similarly, as you we have collected the data, and we have seen that, so the relationship is negative, mean that there is a creativity is high, mean as the creativity increased, the position decreased. Okay, so which means the lower number that you did in the computation, which mean if the position is 1, so that means the actual number is decreasing. Okay, but the creativity is increasing, because if your marks is high, okay, you have the higher marks, that means you have the higher position mean 1, so that's why we are saying in terms of numbers it is decreasing. So that's where the interpretation will be, as the creativity increases, position decreasing from 4 to 3, 3 to 2, 2 to 1. Okay, so which mean we can say that as the creativity increases, so did the success in the competition is also increases. Okay. Furthermore, if you want to apply the candles, so same kind of result we are getting. So they have the strong correlation between the creativity and the position. Okay, and we can also see that they have the negative relationship. As the creativity score start increasing, the position is decreasing. The position decreasing means it become from 4 to 3, 3 to 2, 2 to 1. Okay, so I believe it's clear how you can interpret these results, whether you are going to apply the Spearman's or a Spearman's test or a Kendall's correlation coefficient. Okay, now let me discuss regarding the bootstrapping. As we have discussed earlier that if your data do not follow the normal distribution, so the third technique you can apply, that is a bootstrapping. And what is a bootstrapping is basically a statistical procedure to resample the data set. Okay, so which means you can create with replacement sampling that data again and again and as many times as you want. Okay, okay. So for that in R, what we need to do is we need a library called boot. So that means first of all we need to install this and then call it. And then what I am saying that I'm using this particular function. So what this function is going to do is that is function, then the name of the variable in which we have stored the data. So that is a layer data. Okay, that is basically the layer data set. Okay, which is we have stored in this particular variable. And then I is basically indicating a particular bootstrap sample, because if you want to apply the bootstrapping to generate 2000 or a 10,000 sample. Okay, so for every particular sample we are representing through I. So sample number 1, sample number 2, sample number 3, and so on. So this I is basically representing each bootstrap sample. Okay, and then we are saying find the correlation against every sample, okay, of the variable position and the creativity, and the method you need to apply, that is the Kendall's coefficient, because the data is non-normal. Okay, so the method we are applying, that is Kendall. So either you can apply Pearson or Spearman, it's up to you. And then I'm storing this function in the boot top, and then we need to tell how many time I want to bootstrap the sample. Okay, so for that I am again defining a variable in which I'm calling a function, that is a boot. Okay, then the name of the variable in which we have the data, and then the name of the variable in which we have applied that function, which mean against which two variables we want to find out the correlation and using what method. And then we are indicating the number of bootstrap sample. Okay, and then I am running this particular command, as well as I am running the confidence intervals. So let me run this command first, and then we will analyze the results. So with the help of this command, we can call the data set. Okay, that is basically the biggest layer data. Okay, I can view this data set. Okay, right now I'm using the first two columns. Okay, either we can use simple R commands. Now I want to apply the bootstrap. So library boot. So I have already installed it. Then I am calling this function, run this, and run this. So I'm getting these results. Okay, so how we can interpret this one? So from this, first of all, we can see that this is basically the answer of the Kendall's correlation coefficient, which we have calculated earlier as well. Okay, and furthermore, we can see that there is a very small standard error. Okay, so from the bootstrap, so there is a very small standard error. So that means we can rely on these results, as well as in order to check whether this relationship is significant or not, what we can do is we can use these confidence interval. with the help of norm, basic, percentile, and DCA. If any of this confidence interval containing the value of 0, then against that particular confidence interval, we can say that based on that particular confidence interval, there is no relationship between the two variables. So as we can see that whether we can use this particular confidence interval, whether we can use this or this or this. So none of the confidence interval containing the 0 value, because when we are applying the testing of hypothesis, we say that rho is equal to 0 and alternative mean rho is not equal to 0. So this 0 mean there is no relationship, because none of this confidence interval containing the 0. So from the bootstrapping, we can conclude that there is a significant relationship between the creativity score and the position held. So as the creativity score start increasing, you will get the your position is decreasing. Position decreasing means you are getting basically the higher position in terms of position number 1, 2, 3, right? I hope it's clear how you can perform the correlation analysis in R, the parametric, especially the Pearson correlation coefficient, and how you can interpret it. Similarly, the non-parametric, which is Spearman's, Kendall's, and Bootstrapping. So thank you so much. See you in the next video, in which we will discuss biserial correlation, point biserial correlation, and partial correlation coefficient. Thank you so much. See you in the next video.